This is Dr. Holt. This video is on relative velocity. Relative velocity is going to depend upon some type of reference frame. The reference frame is typically a stationary reference frame relative to the Earth. However, it can be a moving frame. So here I have car A going off to this direction at 40 meters a second. I have car B going off at 30 meters a second. The type of problems we're going to get into is trying to find what is the velocity of car B in respect to car A, or what is the velocity of car A in respect to car B. To work these problems, let me just go over some of the important characteristics and things you should do. The rules is, first thing, I would label each object involved with some type of letter, and that could be A, B, or C. And usually there's going to be 3 objects, however there could be more than 3. One of these will typically be a stationary object like the Earth. Okay, when you do these problems, look for words that such as the velocity of A relative to B. If a velocity is mentioned by not relative to anything, then it's usually going to be relative to the Earth. So if the velocity of a car is given, then the velocity of the car most likely is going to be given in respect to the Earth. If it's like an airplane, typically it's going to be given in respect to the air itself that it's flying through. Now when you do these, you want to assemble them into the following equation, where this says the velocity of A relative to B is going to equal to the velocity of A relative to the Earth minus the velocity of B relative to the Earth. Now if you get confused at all about setting these up, just remember this: whatever's listed first is A, that's going to be that'll be the velocity of A in respect to the Earth, and then B, you're always going to subtract the velocity of B in respect to the Earth. Alright, let's get in and try to work some problems, and I think this will hopefully clarify it. Okay, let's look at this problem. What is the relative velocity of the boat relative to the shore, which is also relative to the Earth? So I go back to this equation here. I'm going to start out here. The velocity of the boat relative to the water, and really we should put these are vectors. And again, I'm not as consistent as I should be with these as far as these being putting the vectors over the top, knowing that we know it's a vector. So again, I got the velocity of the boat respect to the water is equal to the velocity of the boat respect to the Earth minus the velocity of the water respect to the Earth. I'm going to use basic algebra, and what I'm looking for is this value right here. So I'm going to move this to the other side, and I will get this, where the velocity of the boat relative to the Earth is equal to the velocity of the boat relative to the water plus the velocity of the water relative to the Earth. Alright, so now we're going to sit there and solve this. So we'll say the velocity of the boat relative to the Earth, which is the same thing as the velocity of the boat relative to the shore, is going to equal to the velocity of the boat relative to the water. Well, if you have a water molecule that's just sitting here and watching this boat, they're both moving down the stream, but in respect to that water molecule, it looks like the boat is going across the water at 5 meters a second. So we will, first thing we should probably do is set this up as some type of orientation. So I'll set up an axis system here. And it's really, you should probably do this before you even start the problem. I'll make this be my positive y. I'll let this be my positive x. So in respect to this, I would get 0 I hat. Because the water molecule, it does not look like that boat is moving down the river. From the water molecule's perspective, they're both moving down, so it looks like the boat's moving across. So we'll put plus 5 j hat. Alright, so now we got that one done. We come to the velocity of the water in respect to the Earth. Well, in respect to the Earth, this is being the Earth, if you're watching the water go down, this water molecule looks like it's going down the river at 3 meters a second. So we'll put 3 I hat plus 0 j hat. Alright, remember these are vector quantities, so now we'll just simplify the velocity of the boat in respect to the Earth or the shore is going to equal to the sum of these, which will be 3 I hat plus 5 j hat. Okay, I'll just draw roughly what's taking place here. We got the vector coming over here, a 3, we got one coming back up at 5. So we're going to be looking for this vector right here. We will label this as 3 and label this as 5. we would go to Pythagorean theorem. 3 squared is 9, plus 5 squared, which is 25. That gives me 34. So this value here would equal to the square root of 34. That's your magnitude there. So then we would find this angle here, and we know that theta here is going to be the inverse tangent of 5 divided by 3. If we do the math, then we could say the velocity of the boat in respect to the earth, which is the shore, is equal to the square root of 34 at an angle of 59.4 degrees. And you should show where that's coming from. Oh, let me draw a low horizontal. And really ought to move that. Grab that, move that into. Oops. Let's just move. I tell you what. Let's just move this back in place. Maybe if I grab it, let's grab this, and just like that. And that's how you would show your answers on this particular problem. All right. Let's go to another problem. This problem is going to be very similar. It's going to be another river problem. Here, let's find out what is the velocity of this boat relative to the green shore. Again, I've drawn put my equations down. We're going to work it just like we did before. We're going to isolate this, so we're going to move the other side. And we'll do this. Again, we'll draw our orientation so we know what axis. I'll draw it over. I'll just draw it right here. Nope, got it jerked on me here. Come straight down. We come straight over. We will label this as positive y. We'll label this as positive x. So we're going to work with this equation here. We're going to go back, and first thing we're going to do is find out what is the velocity of the boat in respect to the water. Well, again, if you have a water molecule just sitting there watching this boat go across, okay, it looks like from the water molecules that this boat is moving in this direction right here in respect to the water molecule. Alright, so we'll write those values down. So we'll say the velocity of the boat in respect to the earth is equal to, now we'll do this, velocity of the boat. Well, we know that the x value is going to be 6 cosine 60 degrees. We'll make that to be I hat plus 6 sine 60 j hat. Okay, that's just this part right here. Then we'll come down, we're going to do a plus sign here. Now what's the velocity of the water in respect to the earth? Well, in this case it's just going to be 2 I hat. So we'll say plus 2 I hat plus 0 j hat. Alright, so we run those values. Let me grab the calculator real quick. We'll sum up all the I hats. Okay, here we go. We're going to take 6 times the cosine of 60, which is going to be 3, and then plus 2, that gives me the 5. So that's going to equal to 5 I hat. And then we take this value here, 6 times the sine of 60, and I believe it gives you what, 5.2. Okay, so that's what the values are. Now again, I'm going to just draw kind of a rough value of what the vectors would look like. I'd have 5 going this way. I'd have 5.2 going back up this way. Looking for this value right here. Again, I would label this as 5 and then 5.20. We go to Pythagorean theorem. We'll square that plus 25. It's basically, and without rounding, this is going to give me the square root of 52 degrees, and then we need to find theta, get inverse tangent of that for that. So our final answer would be the velocity of the boat in respect to the earth is going to equal to the square root of 52. And then we'll draw the angle. And I'll put the at symbol. And if I do that, I think you get about 46.1 degrees. And that would be the answer. All right, let's do one more problem. All right, this problem's a little unique because we're not so much going to be dealing with the equations. Here on this problem, a pilot wishes to fly a plane north relative to the ground. So the plane wants to get from here to here, but the wind here is blowing 90 kilometers per hour going from west to east. The airspeed of the plane is 200 kilometers per hour. So we know just from the logic the airplane is going to have to go off in this direction to eventually to move this way because the wind is moving back. Now what we can do with this, we can really do this with just vectors if we think about it. Because we know that the velocity, I'll do that in black, we know from our previous work that the velocity of the plane in respect to the earth is equal to the velocity of the plane respect to the wind plus the velocity of the wind respect to the earth. Again, where that is coming from is I just doing this equation here, the velocity of the plane in respect to the wind. Okay, always try to keep these two together. Is equal to the velocity of the plane in respect to the earth plus the velocity I need to subtract, sorry. Get a smaller eraser. Velocity of the plane plane in respect to the earth minus the velocity of the wind in respect to the earth. Okay, so all I'm doing on this problem is I'm solving for this value right here. I'm moving this to the other side, which gives me the addition. So we're really just going to be working with this problem right here. Now, again, we don't know what angle this is. So let's think about what we can do. We know that the velocity of the plane in respect to the wind, it's going this direction, right? If you have an air molecule sitting here from the plane, it looks like the plane is moving off in this direction here. So what you can do with this one is just use it with vectors. Draw something here, because we're going to do velocity of the plane in respect to the wind, and now we're going to do the vector of the velocity of the wind in respect to the earth. Well, from the Earth's perspective, it looks like the wind is going across at 90 kilometers per hour. So we'll draw this vector back this way, because remember when we add vectors, we go from head to tail. Now the resultant vector is going to be from here. Remember, it's tail, tail. We go back up here. Let me just shorten those so it does meet. And the reason I'm drawing this absolutely vertical because we want to go vertically all the way across this point. So now go back and label this, and this would be my 200 kilometer per hour. That's the velocity of the plane in respect to the wind. And then the velocity of the wind in respect to the earth is going to be 90 kilometers per hour. Alright, now to solve this, this is going to be the velocity of the plane in respect to the earth. We can just do Pythagorean theorem. Again, I'll do this in black. So we can say that 90 squared plus the velocity of the plane in respect to the earth squared must equal to 200 squared. So we know the velocity of the plane in respect to the earth is going to equal to the square root of 200 squared minus 90 squared. If you do that, you'll find the velocity of the plane in respect to the earth magnitude is 178.61 kilometers per hour. Now to find the angle, okay, I would probably just do an inverse tangent. I would do the inverse tangent of, write this out, of the 90, which is the opposite, over the 178.61, and we will get a value of 26.74 degrees. Alright, so the way we would show this then is the velocity of the plane in respect to the earth, and now we can show this as a vector quantity because we have everything listed, is equal to 178.61 kilometers per hour. And I would show my, this is a vector quantity, like this. I would show this coming up like this, and then I would show this angle right here as 26.74 degrees. All right, and that would be my correct answer. And we'll go check that, make sure I know what I'm talking about. And yeah, with rounding, yeah, exactly. And it's 26.7 west of north, which we're going west of north. All right, so that's how you set up these problems. There's 3 problems I've solved. Again, when you do these, pretty much follow exactly what I stated here and then go right to this equation. If you follow this approach, you're going to get most of these problems right. You're going to get into some trickier ones, and you may have to, it's going to take some considerable thought, but again, just keep coming back to this equation, manipulate as many times as you can, and you'll finally get the right answer. All right, best of luck.